All right, Chapter 8. We're going to start with 8.1. We'll do about half of it today. We'll do the other half of it when we come back in next class. But variation. Now, we've already talked about this, I think, a little bit back in Chapter 2? Chapter 3, maybe? I think maybe in Chapter 2. But we've got a couple of different types we're going to look at. And the first type we're going to look at is direct variation. And here's the basic idea of what we're doing for direct variation. We're looking at, when we're talking about variation, we're talking about between two different variables. So for direct variation, as one variable gets bigger, or if you want to go on the flip side, if that variable gets smaller, the other variable is going to react in the same way. So the other variable gets bigger if the first variable got bigger, or if the first variable got smaller, then it would get smaller. So whatever you do to one variable, it's going to have the exact same reaction in the other variable. That if one variable gets bigger, the other variable is also going to get bigger. If you make the first variable smaller, then the second variable is going to get smaller. And for direct variation, they always talk about a general equation. And the general equation for direct variation is y equals kx. So if you use direct variation, you're always going to come back to that one equation. And that's going to, basically everything we're going to do is going to spin off that one equation. So we're talking about x and y. Now the k that's here with the x, k is the constant of variation. And somebody in first block asked me, they said, well, why is, if it's the constant of variation, why is it not c? Honestly, I don't know. My guess is because when we do the quadratic formula, we do ax squared plus bx plus c. So they use k to know that it's a totally different number than if we were doing the quadratic. That's my best guess. I'm not really sure there. And if you have to, in some cases, they're going to ask you to find the k. Almost every case, you have to find the k value. If you have this equation to find the k value, k would equal y divided by x. So to find k, k is going to equal y over x. Okay, now some of these, you know, you've actually done in the past when you did geometry and some other places, you've actually done some direct variation equations. So let's just give you an example here. All right, let's see if anybody remembers this one, because somebody's got it somewhere in their memory. What's the formula for area of a circle? Area is pi r, there you go. Area is pi r squared. Because if you take the radius and make it bigger, then what happens to the area? It gets bigger, right? If you take the radius and make it smaller, then the area of the circle is going to get smaller. So that's an example of what direct variation is. And for this one, that pi, that's your k value. So k is equal to pi, which is about 3.14. And that's what the k is. It's some number that's always the same no matter what you do with the equation. You're always going to have one thing that's always going to be the same. That's why they call it the constant of variation. So no matter what size circle you use, you're always going to use pi, which is about 3.14. Now, the one thing, I guess, constant-wise you can do right now, the cost of gas, it's a little bit different, but pretty much anywhere you go right now, the cost of gas is about $2.50 a gallon. You know, maybe a little more, a little less, but that's a constant now. That if you're going to drive, you need to get gas. And if you're getting just 87 unleaded, it's about $2.50 a gallon. You know, give or take a little bit. All right, so what they're going to ask you to do is they're going to ask you to find k-value of the direct variation with an ordered pair of 4, 8. Okay, and as we start doing more and more types of variation, it's the first thing you always have to do is figure out what's the keyword. In that case, it's direct. When we do the next one, the second one we'll look at that we'll get to today is inverse variation. So they'll always have to put that word in there somewhere to let you know which one you're working with, because that tells you which equation you have to use. So for this one, we're going to find the k-value of the direct variation equation with an ordered pair of 4, 8. Okay, so very first thing is you're going to start with your equation, which is y equals kx. And what do you know about an ordered pair? What is the 4 and the 8? What could we put with those two things? There you go. 4 is the x, 8 is the y. So when they give you an ordered pair, you take those two numbers and plug it into this equation and just see what you get. You've got 8 would equal k times 4. So to get the k value by itself, then you would go back in, divide both sides by 4. 8 divided by 4 is 2, so your k value is 2. And if somebody's thinking, well, is it always going to be that easy? Pretty much, yeah. When they give you, now, sometimes when you're doing these, it may be that it's going to be a fraction that if you had to reverse this, if it had been 4 over 8, you would have had a half instead of 2. But to find the k value, it's always pretty simple. You're just going to take the two numbers they give to you, and you're just going to plug it back into the equation. All right, now, most of the time, what they're going to ask you to do after that is they're going to give you this k value. They may tell you now to write the equation with the ordered pair. Okay, and here's where the equation, if you have the k value, here's where it's really easy. You just take the k value, which is 2, and just plug that value of 2 in for the k value. So the equation will just be y equals 2x. Okay, now here's where I'll just ask you a question. Does that look like a equation that we have graphed in the past? That's y equals mx plus b, right? And that's what they're trying to get you to see, is that with direct variation, if we go back up here at the beginning, with the y equals kx, that you could basically think about that as being y equals mx plus b, where m is going to be the slope. In this case, your k value is the slope. The one thing with direct variation equation is this b value is always going to be 0. So you're always going to start at the origin. So that's where they kind of toss out that b value. And that's kind of the same thing with this one. If you were going to graph this equation, you would start at 0, and then you would use your slope of 2, go up 2 and over 1. So they may ask you to graph some of these. And if you do, then just treat it like we're going to do y equals mx plus b. It would basically be that exact same thing. Okay, so that's direct variation. And again, I'm thinking we did that back a few chapters ago when we were going through those. So hopefully that one looks at least a little bit familiar. All right, second equation we're going to look at, the second type of variation, is inverse variation. And with inverse variation, if you think about inverse operations, what's the inverse operation of addition? Subtraction, right? The inverse operation of multiplication is division. So if it's the inverse, you always do it in the other order. You reverse the order. And inverse variation is basically the same thing. As one variable is going to increase, the other one has to decrease. So direct variation, they did the same thing. Inverse variation, you're going to do the opposite thing. Just like for solving equations, you always have to do the inverse variation to solve it. Same thing on this one. One goes up, the other one's going to go down. And that's pretty much your only two options if you're doing inverse, because it's either up or down. If it doesn't change, then there's no variation. And your equation, your basic standard, what they call the general equation here, if we're doing inverse, is y equals k, that's over x. Because if it was direct variation, it was k times x. Well, if we're doing the inverse, we're going to do the opposite. Now it's going to be k divided by x, because it's the opposite of multiplication. Okay, and kind of similar to the last one, that if they ask you to find k, well, to get this k by itself, you would have to multiply both sides by x to get it's divided by x gone. So to find k would just be that it's y times x. So that's your equation, but again, a lot of times you're going to take that equation, and you don't necessarily have to know this part of it, because if you've just got the equation, you can plug in the numbers here and get the k value. So that's not a problem at all. All right, so let's give you an inverse variation problem to look at. And we'll do this one a little bit different, just so that you can see all the different types that we'll have to throw at you. So we're going to find the missing value. Of the inverse variation with the points at 2, 5, and 4y. Okay, now you've got two ordered pairs for this one. So here's where we're going to take it one piece at a time. When you have the first ordered pair, we're going to use it first. So use the first ordered pair. Of 2, 5 to find k. Because any of these equations they give to you, whether it's direct or inverse, the very first thing you want to do is to find out what the k value is. So we set up here at the top of the page that to find the k value, if it's inverse, k is going to equal y times x. So k would equal 5 times 2. So the k value is 10. Okay, now the question didn't say to find the k value. The question said to find the missing value, so we're going to go back and figure out what this y value is, because that's the part we've got missing. So second thing you're going to do is, now we're going to use the second order pair which was 4y, along with this k value we've got right here, along with k equals 10. To find the missing value. And again, you're going to start with that same equation. The equation we're going to use, because it was inverse, was y equals k over x. And then you're going to plug in k equals 10. You're going to plug in 4 for the x and y is y, so that's what we're going to plug in for that part. Okay, so plugging everything in. Y is y, so it stays where it is. The k value is 10. The x value is 4. So now you're just going to simplify 10 over 4. And in that case, if you want to make that to a decimal, that's one of those times where you could leave it 5. You could divide them both by 2 and make it 5 over 2. But for this part, let's just go ahead and divide it out and get that the y value would be 2.5. Okay, so if they give you two ordered pairs, if they only give you one ordered pair, usually there's only one thing to do. Use that one ordered pair to help you figure out what the k value is. And either they'll let you leave just the k value or ask you to write the equation. If they give you two ordered pairs, most of the time they're going to look for one missing part of it back here, whether that's the x or the y, and you've got to go back and figure out what that missing value is going to be. Okay, and then the one thing we'll do for the first half today, and after we do one or two of these, we'll stop and we'll pick back up with this on Monday because it's homecoming day and everybody's pep rallied up and don't need to do too much here. Is they're going to give you a set of values. And they're going to ask you to determine if the relationship is direct, inverse, or neither. Okay, so that's the directions. Now, here's what you're really going to do for this thing. Because, again, I'm trying to give you the idea that sometimes they give you the directions. Here's what they really mean. That you're going to look for a pattern. By multiplying x and y. Or dividing x and y. So this is what the directions you're going to say determine if the relationship is direct or inverse or neither. And all you're going to do then is you're going to multiply the numbers together, the x's and the y's, or you're going to divide the x's and the y's. And you're going to look for a pattern. And that pattern is going to tell you which one it's going to be. Okay, we'll do two examples. Here's one, and then we'll get one more, and that'll be all we'll do for today. Okay, and here's really what they're asking you to do for this part. When they're asking you to determine if the relationship is inverse, direct, or neither, we're really looking for the k value. They're telling me, all right, if you can find a k value that's the same, then there's a pattern that we have for this part. If you're not able to find a k value that's the same, there's not a pattern. So the very first thing is, let's do the multiplying first. So let's do x times y. And let's see what we get. 2 times 15 is 30. 4 times 7.5, still 30. 5 times 6, 30. 15 times 2 is 30. Okay, so if you have a pattern that you've got for this part right here, if you multiply them together and get them the same every time, that tells you that the k value for that thing is 30, because that's the one number we keep getting over and over and over for this thing. Now, here's the second part. Once you've got the right number, and we're going through this, we've got to figure out if it's direct or inverse. And basically on this part, because we did x times y to get the k value, if you go back and look what we said back here, basically you're looking for which way did we get k. If it was k was equal to y times x, right, from inverse. So since these two things are multiplied together to get the k value, that means it's going to be inverse. And the good thing is that, again, as you're kind of going through the notes and you do enough of these, you start to kind of pick up on the patterns. You don't have to flip back and look at your notes every time. But if you're multiplying the numbers together to get 30, then you're good to go. That will get you a inverse equation. Now, the one other thing they might ask you to do, they might ask you to write an equation for that. If they ask you to write an equation, the inverse equation we had back here was y equals k over x. That to get the k value, we multiply 2 together, but this was just the basic equation. And they ask for just an equation, we're going to take this k value we have here and just plug it back in right here. So y would equal 30 over x. Okay, and that's about all they can do with the table. Is they'll ask you, can you find a number that's the same either by multiplying or dividing? And if it is, then you figure out if it's inverse or direct. Again, they might ask for an equation. There may be separate questions where they might have you do that, so it's kind of good practice just at least to look at it. All right, one more of these and then we're done. Okay, for the second one, we'll go with 0.2 for x and 8 for y. We'll do 0.5 and 20, 1 and 40, and then 1.5 and 60. And we'll throw decimals out because we know how much you love decimals and fractions. So we'll show you that this one's actually not too bad. Hopefully. Okay, so the very first thing you want to do is take the easy route first. Let's multiply them together and let's do x times y. So if we do 0.2 times 8, that's 1.6. Okay, now you can go ahead and look at the other numbers because that's 1 times 40 going to be. Well, that's 40, right? Are those numbers anywhere near the same? No. And if they're not exactly the same, then it's not going to work. So x times y is not going to work. So the next thing we're going to do is we're going to divide. Now, when we divide, let's do y divided by x, because if we go back to the direct variation equation, that if you're going to get the k value for direct, it was y divided by x. So when we do this one, you can divide x and y, or you can divide y and x, order doesn't matter, but just so that we get the right number, let's do y divided by x. Okay, so if we do y divided by x, That's 8 divided by 0.2, that's 40. Okay, we'll do the same thing with the next two. We'll take 20 and divide it by 0.5. That one's 40, so we're good there. If we've got 40 divided by 1, we know that's 40, so we're good there. And as long as 60 divided by 1.5 comes out to be 40, then we're all good. So we've got the k value is 40. And again, if you had done x divided by y, you still would have gotten the same number. It just would have been 1 over 40. So that would have kind of been a little bit hard to see. So make sure when you do that, when you do the division, do y divided by x. Okay, so basically this first option, this was going to be the inverse. Since we did division, then that's going to be direct. So if you multiply them together, that first option is always going to be inverse. If the multiplication doesn't work, do division, and that would be direct. And again, if they ask for an equation, the direct equation is y equals k times x. So in this case, we'll put the 40 here, which would make it y equals 40x. Yeah. So do y'all want to see one where there's no relationship, or do you think you're okay? Yeah. Okay. All right. We'll do one more because it goes pretty quick. All right, so for this one, we'll do 0.5 and negative 40. We'll do a negative 1.2 and 12. We'll do 2 and negative 10. And then negative 2.5 and 6. Okay, so we'll just start multiplying. We'll do 0.5 times negative 40. So that's negative 20. Now, you may jump down here and go, oh, well, 2 times negative 10, that's negative 20. All right, well, that one may be true, but you've got to check them all, because what is negative 1.2 times 12? Yeah, negative 14.4, right? So if we multiply those together, that's a different number, and it doesn't matter if there's one number different. Because of that one number that's different here, that one's out. And then for the next one, we'll do y divided by x. Okay, so if we go negative 40 divided by 0.5, that's a negative 80. And again, go to the easy one here. What's negative 10 divided by 2? There you go. Negative 5. So those two are different, so that didn't work either. And since that didn't work, there we go. It's neither. It's not direct, it's not inverse, it's just something else that we don't really know what it would be.